Students, I am Aditya Chakraborty, lecturer in electrical engineering of Sri Ramakrishna Institute of Science and Technology. Today, I am going to discuss about the part 7 lecture of circuit interrupting devices. The first part, that is the air circuit breaker. So, the air circuit breaker is not the air blast circuit breaker. There is a little difference between air circuit breaker and air blast circuit breaker. In case of air blast circuit breaker, the blast effect of air is used to extinguish the arc. But in case of air circuit breaker, the air is static and the arc is flowing through the air, and it is used for low voltage application. In air circuit breaker, the arc is initiated and extinguished in substantially static air in which the arc moves. Such breakers are used for low voltages, generally up to 15 kV and rupturing capacity of 500 megavolt ampere. Air circuit breaker has several advantages over the oil as an arc quenching medium. These are elimination of risk and maintenance associated with the use of oil. Number 2 is the absence of mechanical stress that is set up by gas pressure and oil movement. Number 3, the elimination of the cost of regular oil replacement that arises due to deterioration of oil with the successive braking operation. In the air brake circuit breaker, actually the air circuit breaker is also known as air brake circuit breaker. The contact separation and arc extinction take place in air at atmospheric pressure. In air brake circuit breaker, high resistance principle is employed instead of current zero method. In this circuit breaker, arc is expanded by the means of arc runner, arc chute, and arc resistance is increased by splitting, cooling, and lengthening the gap between the fixed contact and moving contact. So these all are the high resistance methods. And the arc resistance is increased to such an extent that the voltage drop across the arc becomes more than the system voltage, and the arc gets extinguished at the current zero of AC wave. And the last one is the air brake circuit breaker are employed in DC circuit also, and an AC circuit up to 12,000 voltage. Such breakers are usually of indoor type and installed on vertical panels or indoor draw-out circuit breaker or switchgear. AC circuit breakers are widely employed indoor medium voltage and low voltage switchgear. The air circuit breaker can be classified into 3 categories. The first one is the plain brake type air circuit breaker. It is the simplest one in which contacts are made in the shape of 2 horns. The air initially strikes across the shorted distance between the horns and is driven steadily upwards by the convection currents caused by heating of air during arcing and the interaction of the magnetic and the electric field. The arc extends from one tip to the other when the horns are fully separated, resulting in lengthening and cooling the arc. The relative shortness of the process and the possibilities of arc spreading of adjacent metal works limits the application about 500 volt and 2 low power circuits. Now the next one is the magnetic blowout type air circuit breaker. So here you can see the image of magnetic blow type air circuit breaker. So these are the arc chutes. This is the arc horn. These two are. This is the moving contact, and that is the stationary fixed contact. Some air circuit breakers are used in the circuit having voltage up to 11 kV. The arc extension is accomplished using magnetic field provided by the circuit in blowout coils connected in series with the circuit being interrupted. Such coils are called blowout the coil. The magnetic field itself does not extinguish the arc. It simply moves the arc into chutes where the arc is lengthened and it is extinguished, cooled and hence extinguished. The arc shield prevents arc spreading to an adjacent network. It is important to connect the coils at correct polarity so that the arc is directed upwards. As the braking action becomes more effective with large currents, this principle has resulted in increasing the rupturing capacity of such breaker to a higher value. So the puncture strength of the breakers is also increased. Arc chute is an efficient device for arc extension in air and performs the following three interrelated functions. Number one, it confines the arc within a restricted place. So the arc cannot be moved from the contact space, or it actually limited within the restricted place. And it provides magnetic control over the arc movement so as to make arc extension within the device. And it provides for the rapid cooling of arc gases to ensure arc extension by deionization. Now the last type of air circuit breaker, that is air chute air circuit breaker. The normal arrangement of air chute air circuit breaker employed for low and medium voltage circuits. There are two sets of contacts called the main contacts and arcing or auxiliary contacts. Main contacts are usually of copper and conduct the current in the closed position of the breaker. They have low contact resistance and are silver placed or silver plated. The arcing contacts are hard, heat resistant and usually of copper alloy. Arcing contacts are used to relieve the main contacts from damage due to arcing. The arcing contacts are easily renewable when required. The auxiliary and arcing contacts close before and open after the main contacts during the operation. Here the blowouts consist of a steel insert in the arcing chutes. These are so arranged that the magnetic field induced in them by the current in the arc moves it upward still faster. The steel plates divide the arc into a number of arcs in the series, so it is extinguished by the splitting effect. The distribution of voltage along the arc length is not linear, but it is accompanied by a rather large anode and cathode drops. In case the total sum of anode and drop of all the short arcs in series exceeds the system voltage, conditions for the quick extension of the arc are automatically established. When the contact has come in contact with the relatively cool surfaces of the steel plates gets rapidly and effectively cooled. The movement of the arc may be naturally or aided by a magnetic blowout. Thus the arc is extinguished by lightning and increasing the power loss of the arc. So that is a disadvantage because the power loss occurred due to the arc and by the help of lightning. So now the working principle of air circuit breaker. When the fault occurs, the main contacts are separated first and the current is shifted to the arcing contact. Now the arcing contacts are separate and the arc is drawn between them. This arc is forced upwards by the electromagnetic force and the thermal action. The arc ends travel along the arc runner. The arc moves upward and is split by the arc splitter plates. The arc is extinguished by lengthening, cooling and splitting. Okay, so that is mainly the high resistance method of arc extinction. Now the next slide is the application of air circuit breaker. Air circuit breaker is suitable for the control of power station auxiliaries and industrial plants. They do not require any additional equipment such as compressor, etc. They are mainly used in a place where there are possibilities of fire or explosion hazard. Air brake principle of lengthening of the arc runner's magnetic blow off is employed for DC circuit breaker also up to 15 kV. Now the next slide is the disadvantage or drawbacks of air circuit breaker. A drawback of CHUTE principle is inefficiency of low current where the electromagnetic field are weak because it acts by the help of electromagnetic field. So if the current is low, then electromagnetic field is also low. The CHUTE itself is not necessarily less efficient in its lengthening and deionization action than at high currents, but the arc movement into the CHUTE tends to become slower due to the low current and high speed interruption is not necessarily obtained. So that is a small drawback of air circuit breaker. That's all for today. Thank you.